All right, so on this problem, what we're going to do is we're going to look at how to use implicit differentiation. And while we do this, there's some things going on here that we're going to have to pay attention to. Okay, first off, both parts of this equation have chain rule that's going on. And both parts of this equation have product rule that's going on, okay? The chain is really minor. The chain deals with derivative of y, okay? But it's there nonetheless. So establish what u and v are so that we can use our product rule here. And then I'm just going to look at this first part here in blue. So u is going to be in red, v is in green. The derivative of u is 2x times v, that's just y, plus the first guy, which is x squared, times the derivative of y. And the derivative of y is dy dx. Okay, that's implicit differentiation right there. It's no different than if I had said, okay, y equals 4x to the fifth minus 7x. What's the derivative of that? You would write down dy dx equals, and then 20x to the fourth minus 7, okay? You would do that already. So that's why after, when we do this product rule right here, the derivative of y is dy dx, okay? So then let's look at the second part with u and v. And when we look at that guy, it's the first times the derivative of the second, which is 2y. And then here's your chain rule, 2y times derivative of y, which is dy dx, plus the derivative of the first times the second. So that whole product rule is in purple. Okay, so one product rule in blue, one product rule in purple. The calculus now is done. All we've got to do now is go through and sort out how to get this guy reduced back down and get maybe combine some like terms. Okay, so what I want to do is I want to solve for dy dx, and in order to do that, I'm going to subtract over the 2xy and the y squared, so that I just have dy dx items on the left. And then I'm going to factor out the dy dx, because if you'll notice on the left, the only things left are things with dy dx. And then my last step, and I'm going to show it in red, is to divide by the x squared plus 2xy. When I divide by x squared plus 2xy, that eliminates everything on the left-hand side except for dy dx. And it gives me the equation that I've got, which is negative 2xy minus y squared, all that over x squared plus 2xy. Now, you cannot factor anything out of this. The only time you can factor things out is when everything that you're factoring out is in each different part of your equation. And right here, we have no items that are in all four parts of this equation. So here's your final answer. And this would be how you would show a derivative using implicit differentiation.